Nevertheless, a growing number of young people felt that they were excluded from participating in the computer revolution. They began to dream of a day when they would own their own computers and use them not just for calculating, but for anything they chose.
This was the thing we had grown up to love. When I was in high school, I told my father that someday, back then the mini computer with 4K of RAM cost as much as a house. I told my father, I've decided that someday I'm going to have an apartment instead of a house, and I'm going to buy myself a computer. I'm going to be the one person that owns a computer.
Steve Wozniak and his partner Steve Jobs would help write the next chapter of the computer revolution, putting the power of the computer into the hands of millions of people. The key to making computers easy to use lay in the way children learned. By observing children growing up, psychologists have seen that at different stages, children perceive the world in quite different ways. Very young children explore the world through touch, reaching and grabbing objects. For children of 5 or 6, the visual mentality is more important. The Swiss psychologist Jean Piaget had shown just how strong it was in a series of classic experiments.
Well, Dr. Inhelder here is filling one glass with milk. Then she's asking the child to fill his with exactly the same amount as she has in hers.
For children like this 5-year-old, the visual mentality is so dominant that they may be led into error. Here, the child has to decide whether 2 glasses have the same amount of milk in them. After the child is happy that the 2 glasses contain equal amounts, the investigator makes her move.
I would prefer to drink my milk in the tall glass. I have poured it all in the tall glass. You and I, have we still the same amount?
No.
Who has more? In this glass? But how do you know? Because it is taller.
Later on, we learn to handle symbolic reasoning with difficulty.
In such a way that they're understandable to us. I can't hear you, Marty.
Many people find things like algebra confusing. It's not surprising that they had found the symbolic language of computers impossible. But the intuitive mentalities of touch and vision stay with us all our lives. We are all expert at seeing something, reaching out and grabbing it. The Xerox scientists realized that this was the key to making computers easy to use. By programming the computer to control the elements of a television screen, they created an illusion of a paper-like surface on which pictures could be drawn and animated. Doug Engelbart's mouse was the perfect manipulative device. It fitted into the hand, and with it one could reach out and grab objects on the screen and move them around. Sophisticated software enabled the unfriendly computer to simulate a world the user already understood. This paint program from 1972 made the act of painting on a computer remarkably similar to painting in the real world. Other software enabled letters to be formed, or music to be written and transcribed. Software apparently could change the computer from a forbidding machine into a friendly mental tool.
What we realized was that we could create what some people called a user illusion, something that appeared to be a world on a screen. One way to think about it is if you play a video game, there's an illusion of spaceships or of roads and cars, or depending on the kind of game. And the user who gets engrossed in the game starts operating as if they're really working in the real world, when in fact they're only working in this imaginary simulated world created by the sequence of steps in the computer program. So what we realized was that we could create an illusion, for example, of an office with folders and documents and file cabinets in the office, and that instead of having the user learn complicated and unfamiliar technological terms, we could use the metaphor of the office, for example, and talk about opening files and closing files and editing documents and other terms that were much more familiar to people.
By the early 70s, Xerox scientists with their Alto office system had demonstrated the future. But at $45,000 a time, few users could afford it. This was one reason why Xerox decided not to market it.
The reason no one's heard of it is because it wasn't made into a successful product. Now, are you asking why wasn't it made into a successful product? The short answer is that that research was done in the context of a copier company, not a computer company.
And when it came down to it, this copier company was not ready to launch headlong into the personal computer revolution. By itself, the brilliant work of Xerox PARC wasn't enough to change the world of computing. Before the computer would become commonplace, it had to become smaller and cheaper.
A few miles from Xerox PARC in Silicon Valley, the electronics capital of the world, a revolution was underway. Each year, engineers vied with each other to stuff more and more electronic circuitry onto tiny wafers of silicon. Computers which once filled a room had been squeezed into boxes the size of refrigerators. And in 1970, the silicon wizards had gone a step further, putting the main circuitry of a computer on a chip which could be mass-produced. The microprocessor could totally change the economics of computing. Computers need no longer be priceless objects. Microprocessors, if mass-produced, could become cheap enough to be disposable.
I had one case where I was being interviewed by somebody from a magazine who kept asking questions about testing. But I realized after this questioning went on for a while that they weren't really talking about testing, they were talking about repair. And they had the idea that somehow somebody was going to have to take their soldering iron and go down inside the chip and try to move wires around. And then once I realized what they were really asking, I said, oh no, it's not like that at all. It's like a light bulb. When it burns out, you unplug it and you throw it in the garbage and plug in a new one. And they were just dumbfounded at the idea that a computer could be so inexpensive you'd think about throwing it away.
I was on a panel with a couple of other people from large computer companies, and we're talking about the prospects for the microprocessor. One of the other panelists said, I wouldn't want to have my computer such that if I dropped it on the floor, it would fall in a crack and I'd lose it. And I said, you don't understand. If you can drop it in a crack and lose it, there's millions more where that came from.
In the mid-70s, corporate giants like IBM weren't convinced that a real mass market in computers would ever exist. Unaware of the brilliant work of Xerox PARC, they saw their customers as limited to scientific and business institutions. But there was a group who desperately wanted their own computers. People who'd grown up on the fringes of the computer establishment. Technical hobbyists who'd used computers at universities and knew their remarkable versatility. Before the microprocessor, their dreams seemed absurd. Now, perhaps, things would change. In January 1975, the front cover of Popular Electronics featured a computer kit called the Altair for the unheard-of price of $500. Based on a microprocessor, you had to assemble it yourself. And when assembled, it did almost nothing. If people did want to own their computer, here, finally, was the opportunity.
And what happened was all this pent-up demand, a sort of latent understanding everybody had of what computers could do, suddenly was allowed to burst forth. People drove all night to get their computer kits. Why do people read the popular mechanics magazines? Because they dream of all the things they could do if. And suddenly here was a new if. If only I had this computer, I could keep track of everything, I could learn everything, I could be creative in every possible way. And so it began.